Hey, my name is Panav Mhatre, and I'm the host of the Spot Robotics Podcast. Welcome. It's been a while since the last one, but I've been working really hard to get some cool guests on the show and improving the overall episode quality. Today, I'm joined with my guest, Mr. Akshaj Dhamavram, discussing AI and the overall future of AI. This was a super informational episode, and he brought us some really unique takes on the whole AI movement, which I really loved. So, I hope you enjoy this podcast where you can gain insights into technology in the modern world and get a new perspective and advice on succeeding in these fields. If you enjoyed the podcast, follow us on wherever you get your podcast, and if you'd like to support us even more, give us a review. Thank you, and enjoy. Okay, so for my first question, I'm going to start off with just asking you, what do you do currently, and I guess your job at Motional, and what does your day-to-day activities look like, and how do you feel about your overall job right now?
So I guess what I do at Motional is basically I'm a machine learning engineer, or like you can call it a research engineer, a software engineer, whatever. But basically, what we do is when we have a self-driving car, once we observe our scene, we know that there are like pedestrians, there are bicyclists, there's like a stop sign, there are traffic lights. And so now that we know what's in our scene, we want to kind of predict what is going to happen before it happens. And then once you can kind of predict the future, you want to kind of plan around that future. So we do both basically. We do this prediction and planning. So that's what I work on. So specifically work on like scene encoding and planning based on the scene encoding. So what do I do? How does the job look? I guess it's more about thinking about the problems. What we do is we read a lot of research papers. Um, we see what other people are doing in the industry. This is constantly changing, so there are like always new innovations coming out. We also look at like adjacent industries like natural language processing. So the whole Chat GPT that came out, we want to kind of create those similar foundation models for our cars as well, right? So we want something like a decoder heavy like Chat GPT model. We want to do that for our cars. So that's kind of how it looks. We think a lot, we code a lot of software design because that's also very important. Where it's not only just like AI models, but like what is the surrounding infrastructure that helps these models? How do you make it faster? How do you make the next software update faster? So like once you have a V1, how does V2 look? How does V3 look? You want to kind of build for a long-term scalable process. So we build all of the software surrounding that. We talk to adjacent teams like planning, controls, perception. We want to make the whole pipeline smoother. We want to also like get this onto the car. So it's not only just like theorizing this and running in a simulated space, but we want to take this, we want to deploy it on the car, and that's like a huge headache in and itself. So we have to basically build the entire thing. And that's the great part about, I guess, Motional in general. It's where it's very research heavy, it's very cutting edge, but you also need to like get this out. And that's like a very demanding task. Um, Sorry, were those all the questions, or did I miss any?
No, that's good.
Perfect.
I guess we can move to the next question. So I know you did I think college in India, right? And
Mhm.
I want to basically ask you, since you also came here and did a master's degree at Carnegie Mellon, if I'm correct.
Mhm.
So I want to basically ask you, for us high school students who are here in in the United States who are listening, what
Mhm.
is some difference between college experience here in the United States and college experience in India
I think that's a
and
good
like
question.
technology?
I think that's kind of like so I grew up here in California,
Hmm.
and so what happened was like my parents took me back to India because they wanted me to get like this experience of like a developing country and like how basically money influences people's behaviors and like struggles and kind of get the and kind of understand and grow in such an environment. So I guess like to answer your question, um, usually like Asian countries. It's not like India in general because I do have like a bunch of other friends in other Asian countries like Korea, China. Usually these countries are very, very competitive. Uh, and it's kind of because we you're kind of like put in this like um, classroom, I guess, and everyone's kind of competing for the same jobs, same colleges, and just the population is just much like larger than I guess here in America. So um so yes, I think it's a lot more like cutthroat. And the whole immigration process is very different. So I guess here in America, you're trying to like stay in America. Well, most people do. But in India, what you're trying to do is you're trying to beat your classmates to kind of immigrate to America. So the whole thinking process is very, very different. And the optimizations that you do are very different. So I guess the optimizations that I did and many of my classmates also did were very, very research heavy. And so that's because we all wanted to get into grad school. So we all started publishing at the end of undergrad. We all started like going and taking up these research internships, which is very different from, I guess, like here in the States, where you're trying to get an internship at, say, a company, and you want to kind of like, I don't know, build an app for the company, build a button or something, and push it out, put that on your resume to get your next internship and then a job at the company. But over here, it's more like, how do we publish? How do we get? What is the cutting edge? How do we like? Who is publishing at this cutting edge, and how do we work with them, and then kind of get into the PhD tracks and so forth. So that's, I guess, the difference. And yeah, that's basically it.
So I guess I want to follow up on. Basically, you said that you moved back to India, and I guess so your parents could like instill some values. I want to ask if any of the experiences in India really
Mhm.
impacted you like today, or like anytime when you work in your job, like anything that really impacted you like from there.
Yeah, I guess it's more like so you kind of understand what or I guess understanding is not the right word. You're more grateful for what you have, and when you kind of understand how other people are and how like I guess people who are less fortunate, like monetarily, or live, you kind of want to contribute back to that. And so even though right now we're in this AI space, and AI, I guess, in its current form does have like the capabilities of like taking away some jobs and like I don't know, putting people out of jobs. Basically, that's the biggest thing that's on Twitter right now. Um, there are people in the field that are basically trying to make sure that that doesn't happen. We're trying to make sure that with AI, we kind of grow the space, we kind of make more jobs, we kind of make this in a more scalable and sustainable fashion. So I guess that's how it has impacted me because I've seen those people. I know who we're going to affect, and we don't want to cause this like collateral damage that just destroys industries. And yeah, that's basically like it's kind of like the fact that you've seen them and you've interacted with them that you know what's at stake.
So I guess now talking about I guess Carnegie Mellon. So I know like a bunch of people do research in like when they're in their master's program. I want to ask, what research did you do, and I guess what really motivated you to do that research at Carnegie Mellon?
Oh, that's a that's a good question. So I did the research. So my research was very very similar to what I work on right now, and that's kind of also how I got this job. So I'm also pretty lucky to do like the exact same research, but get paid a lot more and like also deployed on the car. So what I worked on was basically something similar. So let's just say that you have like multiple different actors. We call them actors. They can be pedestrians, they can be bicyclists, other cars, whatever. Now you have multiple different actors, and all of them are they're all what we call intelligent beings. So they're not like just a, a robot that does something specific based on what it sees. They all have their own intentions. They all have like their own goals, which are kind of the same thing, I guess. But they're basically interactions between actors that we want to encode and understand. So if you take a left, for example, and if I also want to take a left, then I might have to slow down and yield to you, and then let you pass, and then I could follow. Or if I'm more aggressive, I could cut you off and kind of edge you out so that I can take the left turn. So these are all kind of situations that are dependent on actors. And I wanted to kind of model this. And so what I did was we created this new like self-supervised loss function. So self-supervised right now is a very, very like buzzwordy term. But when I was doing it, it was not. It was like just everybody was like it was an interesting thing. And again, you what you will see is like as I've kind of like grown and like over the past decade or so, the stuff that I've worked on was not really like when people look at it, they would think that, oh, it's cutting edge and this guy worked on the cutting edge stuff. But at the time, it wasn't. It was just ordinary stuff. So self-supervised learning was kind of what I introduced into that framework. And what we were trying to do is we were trying to make these loss functions a lot more stable. And there is this like, without going too deep, there is this rotation factor that happens when you're trying to train these loss functions. And so you don't want to like have this rotating around, and you just kind of want to make it a lot more stable. So that's basically what I did.
Okay. I guess the next question I want to go into, I know you talked about, I guess I want to talk about what made you select Carnegie Mellon, I guess, like as your graduate school over any other
Fantastic.
schools.
Like I would say it's just amazing. Like I'm here
Hmm.
in Boston, and
Hmm.
like I
Excellent.
do have friends at like Harvard, MIT. I do visit my friend at UT Austin too. Um, I don't know. I just like it's honestly really, really good. And I just like heard experiences, never actually visited it. So when I went there and actually like experienced it, I I was like, yeah, this is fantastic. It's just a fantastic experience. The only issue is, I guess, like Pittsburgh. Pittsburgh is a rather like small city, so so yeah, that's kind of like, I guess rents are cheap, so it's like I guess it's fine. But living there is just like a whole another ordeal altogether. So otherwise, the university is just,
Mhm.
I think, way better than pretty much anything out there.
Mhm. So I guess the next question I want to really ask you is, I think previously you mentioned about like NLP. So I
Hmm?
mean, how do you guys see like, I guess, the increased attention of, I guess, like language models in general, like the constant development of them with, like, how do you guys see that being like an impact to I guess your job or like the job of developers or people trying to in general?
I don't think I think it's just overhyped. So okay, just to give you like a sense of like how NLP is, I guess, connected
Mm-hmm.
to us. Um, so all these large language models work on what we call sequences. So like a sentence is a sequence of words. So anything that's a sequence of something can be put into these what we call transformers. That's what these large language models are. And so whatever happens in the NLP field, we do pay very close attention because like we use the same stuff. Like whatever they use, we use. And we just swap out the inputs and outputs. Um, so so yes, I guess the way the NLP field is going, it has completely saturated. Um, I have also like I I felt this for like a very long time. That's why I really didn't enter the NLP field, because it was quite boring, which we could get into like very soon. And I guess like what we could talk about, like mature fields. So I would say like NLP is at its maximum maturity, I guess, or its
Mm-hmm.
peak. And even if you were to work in this NLP field, what is going to happen is you aren't going to work on the models per se. What you are going to work on is something called like maybe RAG, maybe prompt engineering. So these are all like terms that if you can dig a little bit, you'll be able to get some resources on. But you're not working on like anything AI specific. So most stuff that you see like AI stuff in NLP is not really AI. It's just like clever ways of using these models, which is like, yeah, I don't want to get too
Mm-hmm.
technical, but yes. So NLP is great, but they've over optimized, and I guess there's a lot more scope of just taking what they've done, throwing it over here, and building new models. So that's the way we see it.
So I guess you were talking about, I guess, NLP being at its mature stage. What do you see some, I guess, other fields in AI that are, I guess, developing, like,
Hmm.
that you see that are developing that aren't really talked about that much?
That's a very good question. I think AI in itself is pretty mature at this point. Like,
Mm-hmm. Yeah.
um, that's I guess
Mm-hmm.
that's where we are. So I don't know if you know this like Gardner hype cycle. It's basically this. It's a hype cycle basically where um, you you have like not much interest, and the interest slowly starts to grow until basically there's this peak, and after this peak, interest just drops all the way to the bottom, and then it slowly kind of like creeps back
Mm-hmm.
up. So um, over the past 10 years, like I've been here, I think we have reached we have hit pretty much all the big problems. Or maybe there could be like some smaller problems. I guess like reinforcement learning could be like the next frontier, but like we have solved a lot of reinforcement learning problems as well. It's more about like trying to like get this into production. Maybe like robots could be the next thing, but again, those are not very like researchy problems. Those are more like very solid fundamental type of like create your fundamental designs, your software design, and kind of iterate. So in essence, like especially if your audience is like in middle school or high school, um, it's not wise to be targeting AI. Mainly because I guess there's like this analogy of like of a train. So let's just say that, or a bus, whatever. Let's just say that you're walking to a bus stop or you're walking to a train station, and you're like, I don't know, 10 minutes away or something. You're not going to pick the train that's already at the bus stop or at the train station. You're going to kind of shoot for the one that's coming in from like the next station or something, right? So you're going to look for stuff that are 10 minutes out so that when you get to the station, the bus is there and then you could take it and leave. So that's kind of what I did. And um, I guess like we can talk about like my journey to getting to where I am right
Mhm.
now, but it was always about what was going to come. And that's basically why I'm over here. If you aim for the stuff that are already there, you just will not hit it. And AI is like pretty mature at this point.
So I guess, I mean, I was gonna get into what really made you get into to AI in general. Like, I guess what was that? What was the experience or like the reason why you got into AI and really want to get into a career into machine learning and AI?
I think it was like there wasn't like one specific thing, but it was more
Mhm.
like a gradual process. So I guess like even as a young kid, I was interested in like science, I guess. And there was this thing, I guess, maybe when I was like early, maybe like middle school-ish, I guess. So Iron Man came out. Iron Man came out, and at the time, like when we were all young, like I don't know, like we were like young kids at that time, everybody wanted to be Tony Stark. And then soon after, like the iPhone came out, and so when Steve Jobs came out with like the iPhone and the iPhone 4 and the 4S and stuff, those are all like things we've never seen before. And so, and I think shortly after, like Elon Musk came out with his like rockets that land themselves. So all of these were like really, really crazy things that wanted me to get into this like whole AI space because like there was Siri from on the iPhone, there was Jarvis on like Tony Stark's like helmet. They used like I guess at the time like right now we could consider like the self landing rockets as a little bit primitive AI, but that was still like the AI they used at the time. There was also like DeepMind. So when I was in undergrad, DeepMind came up with their AlphaGo. They came up with their DQNs to train on Atari, and so all of these basically are like very very strong signals that AI is the next bus on its way. So I do have like other friends who went into like crypto and stuff who are doing like pretty well. It just so happened that like crypto just did not reach the level that AI did. So everybody kind of bets on different things based on their interests, based on what they think is going to be the next big thing. Crypto is also like I feel like it's still on its way, I
Mhm.
guess. Um, but yeah, that's kind of what got me into it. So like seeing these people, well, I guess that you could say fiction, some like Tony Stark is fictional, I guess, but like Steve Jobs, Elon, and then DeepMind and stuff. So also like I guess as an undergrad, like I double majored in like computer science and electrical engineering. So I wanted to kind of like work in the intersection. So robotics was like a very good fit at the time. So I wanted to work on like AI for my computer science thesis, and I wanted to work on like controls for my electrical thesis. And so reinforcement learning was just like perfect in both cases. So that's basically kind of what got me in through the door.
So I mean, you were talking about like the next. What do you think the next, I guess, bus in your analogy would be like next frontier for like people to actually chase for rather than AI?
That's a very good question.
Yeah. I
I haven't
mean,
been looking for buses actually because like
mhm.
that's kind of that's what you guys should be doing.
Yeah.
Um, okay, let me think about it. There, so
Probably
one more
something.
thing is, one more thing is like
Mhm.
if we kind of map AI to other product categories, right? Let's just take the iPhone for example. The iPhone released sometime in like 2008 or something, like, um, and it took a very, very long time to mature. So I guess like right now we could still have like a decade more of just maturing as a
Mhm.
field. Like AI could just mature, and that could you could still be
Mhm.
in the industry. It's just that most of the big stuff have already been done.
Mhm.
Um, but just like the iPhone, like things keep like you always get a new iPhone every year, and there's always new updates coming up. The next there's also like VR coming up, and I feel
Mhm.
like glasses are definitely gonna just like completely open up another space. Like if we can get like optics figured out, and we can get like those AR glasses, that is definitely gonna be a big thing. Because like I have like these meta glasses,
Mhm.
and they're like glasses, and you can see like the potential of these glasses. So in that space, like basically you would have AI mixing with other things. And I guess maybe as like advice to like kids your age, it would make more sense to work in intersections of fields as opposed to just fields, right?
Mhm.
So like working in the computer science space might not be the best idea, I guess, moving forward, because they're kind of solved problems, I guess. Unless like something kind of breaks through the door, you kind of want to work on using something from like CS or something and putting it somewhere else. And it could be like chemistry, it could be like electrical engineering. I did it for electrical engineering because like reinforcement learning is basically using AI for controlling, which is kind of what we do even today in the cars, right? So we're trying to use our AI models to figure out plans and controls for our cars. And so if you were to think of like what are the next big things, I would say using things that work, mature, um, I guess, products for unsolved problems. And you see this like happening in DeepMind where they have like they're using AI for genomics and stuff like that. So you do have like you will see this actually where industries other than CS or other than tech are very, very low tech. Like there's just such a huge gap. Like the tech industry is working on like cutting edge AI, and every other field is still stuck in like Excel spreadsheets and stuff. Like it's
Mhm.
just mind-boggling that there's such a huge discrepancy in what's going on. Um, I know that like one of my friend's parents made the he made like millions and millions of dollars. He made a company that basically does this scheduling, I think, or something like something for hospitals, and just made like hundreds of millions of dollars on that.
Mhm.
So, and he was like a CS guy. So basically, taking something that we know. So obviously, if you would have made that in the tech industry, that would have been crazy.
Yeah.
Like nobody would have wanted that product. So, yes, if you're looking for stuff, then it's obviously mixing two of them together. That would that's just a lot easier to do also.
So I guess my next question would be, I guess, for those who are interested in pursuing in, I guess, computer science and AI, but want to, like, I guess, how could you expand the technical skills so that you could apply it to just other industries? So just expand your own technical skills. Like, what would you recommend for high school students to do?
Hmm. That's a good question. So computer science is actually relatively simple to learn.
Hmm.
I would say it's like on the easier end of all the
Hmm.
engineering degrees. So, and this is like, I'm not like pulling this like out of thin air. It's like I have done two majors and I can compare like computer science and like a hardcore electrical engineering degree. And they are very, very different in like difficulty. So the the way you'd go about this is I think it's called like you just tackle the biggest problem first, right? So if you're more passionate about like physics or like whatever, right? You you look into that and learn CS, which is like very easy to pick up, and keep translating stuff from here to whatever field you're interested in, which makes a lot more sense actually. And there's just a lot more scope for people like that in the industry as opposed to just like a bunch of like another CS grad. It's not advised to just be a CS grad, especially like moving forward. It's just too, you're just like one among like the millions out there.
So I guess my next question would be, I guess, on a scale of 1 to 10, I feel like, I mean, I guess right now, like you said that AI is playing a role in our lives, but do you think in the future, do you think
Mhm.
it would play even a more important role, or do you think it's already hit that peak that
Oh,
it's like,
it hasn't hit the peak yet. Like
mhm,
it's so even if you look at like I
mhm,
guess let's compare it to the iPhone because like everybody
mhm,
knows what happened, so it's very easy to compare. Um, I guess like peak innovation in the iPhone kind of it happened something around like iPhone 5 or 5S. Like
mhm,
that is where like we had that rectangular box, we had the screen, um, maybe like a fingerprint reader for like
mhm,
authentication. The fingerprint reader now became like Face ID, whatever. But we had like all the basic concepts locked in. And from that time onwards, the iPhone really has not changed that much. It's been like
mhm,
we've been updating it, but nothing has changed. Like the fundamentals are locked in. And so AI would basically have a similar trajectory. So the fundamentals are pretty much locked in. I think like I would be very, very surprised if we can go further than Transformers. Like
mhm,
I think Transformers is a fascinating innovation. The self-supervision is fascinating. We're using Transformers for vision now. Like
mhm.
it is very, very hard to like kind of move away from this. Um, and like previously, to give you some context, like there were like I guess feed-forward neural networks before, and those are like fundamentally different from Transformers. Like Transformers is a completely new architecture. Like what ChatGPT has, it's fundamentally like different. And we kind of locked in the perfect architecture. That's my opinion. I think at least for the next like whatever few years, until someone comes out with some even crazier architecture, which I don't think will happen. But going back to the iPhone analogy, it's locked in, and now we just got to perfect it, and we will perfect it in like whatever field is possible at this point. Like put it into healthcare, put it into like robots, put it into I don't know, scheduling trains. I don't whatever. That is basically going to be the next place where you can squeeze things out, and that's kind of why I was telling you to like double major, get like understand different fields and how we can use AI for the other fields. Because at this point, you need more in-depth knowledge in the field that you're applying it to as opposed to AI. Because if you want like deep understanding of AI, you'd only need that if you're creating fundamentally new architectures. But if you're entering a mature field, the architectures are not changing. So what you actually need are like deep understandings in the field that you're applying it to. So that's basically how I'd
mhm.
see it mature, basically.
I guess so. I guess we could run a little bit out of time, but my next question, I guess, would be, I mean, I think you might have talked about it a little bit, but I guess what are some challenges that you face as a machine learning engineer right now, if any?
Yeah, good design. I think like so it's really, really important that we create not just the AI model, but the software that builds the AI model. That's very important. So like it's kind of like version like the version one of the model, the version two of the model. Like even if you think like ChatGPT is like a ChatGPT. It's like ChatGPT 4 right now. It's a GPT
Hmm.
4. So GPT 4 is its fourth version. One wasn't that great. Two was kind of good, and three is kind of where it started picking up. So when you're trying to create models, the main thing is not the model, but it's like the surrounding infrastructure to create the model, and it's like the versions, like kind of improving and improving and getting better and better. So that's what I feel like a lot of people in the industry get wrong. they always think it's about the model. Like, let's create the best model tomorrow. But that's not the right way. It's about creating the infrastructure to create the model and making it very easy and scalable that if you want to change something, you can swap it out and create a new model. That's where I'd see like the fundamental challenges with AI moving forward, which is going to be a big problem actually.
So I guess what do you think are some of the limitations that AI, like the current AI faces with like infrastructure and everything? Would it just be
Um,
computing?
no, I think it's just like bad engineers. um, it's just like right now the barriers to entry are very low, right?
Mhm.
So people enter into the AI field with like very low background. People are not very experienced, nor do they have like the thought process of building like very fundamentally strong systems. And the system design is just very, very important. So it's just like the engineers are not that good. So we could have like compute, I guess like, yeah, compute is there. Like people are
Mhm.
throwing money at these problems. I mean, it's fine, but if you have like good engineers creating good systems, you can always kind of like work around that.
Mhm.
That's the biggest problem right now. So we just don't have good engineers at all. And because the field just grew so fast that there
Mhm.
aren't people to build it.
I guess my last question is going to be, so when you look at your journey to who you are currently, is there
Mhm.
anything that you would say you wanted to change, or you want to do something better, or something where you reflect upon and you really think that that was something I could have done better, or like that would have been like improved my life better, or something like that?
Yeah,
Is
I,
there?
I, I keep thinking about this. So I guess like when you're, so right now I'm in my mid 20s, and I guess like if you're in your early 20s, I mean, I guess if you're a teenager, you have
Mhm.
no idea what's going on. So every option seems like, um, I don't know, frightening. But when you kind of reach your like early 20s, you have a lot of regret. It's like, oh, I should have done that and I should have done that. But once I guess you reach your mid 20s, you kind of feel like, yeah, the stuff that I did made a lot of sense. And like it worked out. Yeah, I'm just lucky, I guess. I guess like that's also a factor, it's just luck. But one thing I guess I would tell your listeners would be like, even if you're on a track, just stick to it, right? Try to stick to the fundamentals. Try to like, don't take shortcuts. Don't try to like, I don't know, cop out. Stay the course. And usually by the time you're in your mid 20s, like things will work out. It's a long game, but they usually work out from like mid to late 20s. So yeah, just stick to the course. That's what I'd say. So looking back, I guess when I was younger, I did have a lot of regrets, but now looking back, I'd be like, no, it's fine. It's as long as you stay. Just have you heard the saying? Like I guess this is a stock market saying, but it's time in the market that's more important than timing the market. So people try to time the market and buy when it's low, buy when it's and sell when it's high. That won't work. It's more like just staying in the market that would give you the most returns. So that's kind of what I'd say. Just stay the course.
That's a really cool piece of advice. I want to thank you for your
Hmm.
time, for
No worries,
really
no
like
worries.
take for the interview, and